Okay, we start the SeaBat 7101 software by choosing the beamforming mode we want. I take 511 beams equidistant, press start, and the sonar software starts off. Okay, now we'll choose the calibration of the system. This is channel normalization. So next we give some transmit power, and then we see the harbour wall come into view. And now we can clearly see our 511 beams equidistant spacing. Higher data density than the SeaBat 8101. Okay, so here we are in the River Tyne channel, currently flat on the bottom. We're about to go through across a trench. I've selected the autopilot mode, meaning that the sonar will automatically change its range as we go across the trench here. One other thing I'll do is I'll switch on roll stabilization, a new feature of the SeaBat 7101. You can see in the top right here we have roll stabilization selected. You can see the range changing as we cross the channel, as it gets deeper now, down to 20 meters. The purpose of this being less operator interaction with the sonar. You can see that we are still in 511 equidistant beam mode, so we have full swath with uniform data density right the way across from one side to the other. A new feature of the SeaBat 7101 here is the coverage angle, which is selectable from 45 degrees to 150 degrees. If I remain in autopilot mode and then change coverage angle, you can see the swath become narrower. Autopilot automatically still chooses the correct range setting for the given coverage angle. What this means is faster ping rates, so more along track coverage, but less across track coverage. There's two modes, high density and reduced beams. What that means is high density, we squeeze 511 beams into the sector we've chosen. Reduced beams means we chop off the beams that fall outside of the sector we've chosen. One of the benefits of the new SeaBat 7101 processor is that you can now run your data acquisition software on it as well. We're showing RESON's PDS 2000 software. I'll just start with the data recording now. In the middle here you can see a 3D display showing our XYZ data. On the right hand side we have a snippets display at the top and side scan display lower down. We're just passing over a trench here. Notice the difference in depth, which is represented by difference in colour. At the top here we have each instantaneous profile as recorded by the SeaBat multibeam system.